April 1940. In the drawing rooms and design offices of North American Aviation in Inglewood, California, a team of engineers gather around sketches and blueprints that represent a radical departure from conventional thinking. The British Purchasing Commission has approached the company with an unusual request: build fighter aircraft for the Royal Air Force. Rather than license an existing design from another American manufacturer, they propose that North American create an entirely new fighter aircraft from scratch. Dutch Kindleberger, the chief designer and company president, proposes something even more audacious: not merely to build an aircraft, but to design and build a prototype in exactly 102 days. The timeline seems impossible to everyone except Kindleberger, who believes that by starting fresh rather than adapting existing designs, North American can create something genuinely superior. The company accepts the challenge. October 1, 1940 marks the first flight of the prototype NA-73X, later to be named Mustang by the British. The aircraft that emerges is sleek, efficient, and beautiful in the way that purposeful engineering produces beauty. Every curve and surface optimized for performance. Nothing excessive, nothing wasted. The aircraft's most distinctive feature is its laminar flow wing, an innovation that reduces aerodynamic drag and enables the aircraft to achieve exceptional speed at altitude. By the standards of 1940, it is revolutionary. Yet when the Mustang enters service with the Royal Air Force as a fighter aircraft, it disappoints. The problem is not the airframe. The design is fundamentally sound. The problem is the engine. The Allison V1710 engine, while adequate for low-altitude operations, lacks a two-stage supercharger and cannot maintain power at high altitudes. At 15,000 feet, performance drops dramatically. At 20,000 feet, the aircraft is barely comparable to contemporary German fighters. The RAF, expecting a revolutionary new fighter capable of competing with the Bf-109 and Fw-190, receives instead an aircraft suitable for low-altitude reconnaissance and ground attack. In German military circles, news of the new American fighter is received with contempt. German officers, analyzing reports from neutral observers and intelligence sources, dismiss the Mustang as a mediocre fighter suitable only for third-rate air forces. The aircraft becomes a punchline in Luftwaffe officer clubs, a vehicle that demonstrates American industrial capacity, but not American engineering sophistication. German fighter pilots eagerly await encounters with American Mustangs, confident that the aircraft will be no match for Bf-109s and Fw-190s in aerial combat. The initial assessment seems validated by early combat reports. When Mustangs encountered German fighters in 1942 and early 1943, the results are often disappointing for American pilots. The aircraft, though fast at low altitude and possessed of exceptional range, cannot climb or maneuver effectively at high altitude. The German fighters, designed specifically for high-altitude combat, maintain superiority. In the altitudes where bomber streams typically operate, the transformation of the Mustang from a mediocre fighter into the greatest long-range fighter of the war begins in May 1942 at Rolls-Royce's test facility in Hucknall, England. Major Thomas Hitchcock, an American military attaché in London, has been thinking about the problem of the Mustang's high-altitude deficiency. He knows that Rolls-Royce has developed two-stage, two-speed supercharged variants of their Merlin engine, engines that maintain power at extremely high altitudes. He proposes a radical idea: remove the Allison engine from a captured Mustang airframe and install a Rolls-Royce Merlin 65 in its place. The proposal violates procedures, exceeds authorities, and represents the kind of improvisation that military bureaucracies typically prevent. Hitchcock pushes forward anyway, sending word to North American Aviation and to Wright Field that someone should authorize this experiment. By July 1942, North American receives authorization to convert two Allison-powered Mustangs to Merlin engines. The engineers face a daunting challenge. The Merlin is a different engine with different cooling requirements, different induction systems, and different physical dimensions from the Allison. Simply removing one engine and installing another will not work. The carburetor air intake must be relocated. The cooling systems must be redesigned. The engine mounts must be modified. The propeller must be changed to a larger, four-bladed Hamilton standard propeller optimized for the Merlin's different power characteristics. By November 30th, 1942, the first Merlin-engined Mustang, designated XP-51B, flies for the first time. Pilot Bob Chilton finds himself controlling an aircraft that is, in every meaningful way, a different machine from the Allison-powered version. The performance improvement is described in test reports as nothing short of astounding. The aircraft achieves a level speed of 441 miles per hour at 29,800 feet over 100 miles per hour, faster than the Allison-powered version at that altitude. The rate of climb is approximately doubled. High-altitude handling is dramatically improved. The engine's two-stage supercharger maintains power throughout the entire operational altitude range. For the first time, an American fighter possesses performance characteristics that enable it to compete with the best German high-altitude fighters. Test pilots and engineers understand immediately that the Merlin engine has transformed the Mustang from a promising but flawed design into something genuinely revolutionary. Word spreads rapidly through American military aviation circles. In Germany, the news is received initially with skepticism. German intelligence reports that America has installed a British engine into their fighter aircraft. The response from German military leadership is dismissive. Surely the Americans are simply copying British designs rather than developing their own advanced technology. The conclusion is that the Merlin engine, while adequate for British purposes, will not fundamentally alter the balance of air superiority. German confidence remains unshaken. The first combat missions of the Merlin engine P-51B do not immediately prove the aircraft's superiority. The initial American fighter units equipped with the new model are learning to operate the aircraft under combat conditions, learning its handling characteristics, learning how to employ its exceptional range and speed tactically. The first few months of 1943 see sporadic engagements as American units become comfortable with the aircraft. But by mid-1943, the P-51B has begun to demonstrate its capabilities unmistakably. An encounter over the Mediterranean between P-51Bs and Bf-109s results in the destruction of multiple German fighters without American losses. Another engagement sees P-51Bs taking down FW-190s at altitudes where American fighters previously held an inferior position. German pilots report encounters with a new American fighter that seems to outperform their fighters at all altitudes, that possesses exceptional speed and climb capability, that handles well in extended combat engagements. The reports are initially disbelieved by German command, which assumes the pilots are exaggerating or misidentifying the aircraft. But as reports accumulate and as German losses to the new fighter increase, awareness begins to dawn that something fundamental has changed. The real test of the P-51B's capabilities comes in early 1944, when the United States begins a campaign of strategic bombing deep into Germany. The 8th Air Force plans to strike targets in Berlin itself, a distance that requires bombers to fly over 1,000 miles over hostile territory. Previous bombing campaigns to distant targets like Schweinfurt and Regensburg in late 1943 have resulted in catastrophic losses. The B-17 Flying Fortress and B-24 Liberator bombers, flying unescorted through German airspace, have been slaughtered by Luftwaffe fighters. On October 14, 1943, a mission to Schweinfurt cost the Americans 60 B-17s destroyed in just over 3 hours of continuous attacks. Entire bomber squadrons are decimated. The B-17's defensive armament, though formidable compared to earlier bombers, proves inadequate against sustained fighter attacks. German pilots, flying in coordinated formations, attack from multiple angles, using superior climb performance to position themselves above the bomber streams before diving through and raking the formations with cannon fire. American losses reach levels that the War Department considers unsustainable. The bombing campaign is suspended for deep penetration targets until long-range fighter escort can be provided. The only aircraft in development that might fill this requirement is the P-51B Mustang. The USAF accelerates production. Orders are placed for thousands of aircraft. Factories work around the clock. By March 1944, sufficient P-51Bs have been delivered to equip multiple fighter groups. The first missions to Berlin are scheduled. March 6, 1944. Over 800 American B-17 and B-24 bombers launch from bases in England for the first major daylight bombing raid on Berlin. Over 900 fighters, including 200 P-51Bs, provide escort. The scale of the operation is unprecedented. Previous escort missions have been limited to distances within a few hundred miles of the English coast because previous escort fighters lacked the range to penetrate deep into Germany and still retain fuel for combat. The P-51B, with its exceptional range and the ability to carry drop tanks extending operational radius, makes this deeper penetration possible. American fighters can now accompany bombers all the way to Berlin, engaging German fighters over the target, and still retain sufficient fuel to return to England. The psychological impact on American bomber crews is profound. For the first time, they will not be abandoned over hostile territory. For the first time, fighters will be overhead providing protection. The German reaction is shock followed by aggressive response. German air defense is mobilized completely. Fighters from throughout central Germany are recalled to defend the homeland. Over 800 German fighters rise to meet the American bombing raid. An enormous air battle erupts as American fighters intercept German fighters attempting to approach the bomber stream. The dogfights are intense and widespread across hundreds of miles of sky. American pilots, many of them flying the P-51B for the first time against German fighters, engage in aerial combat at altitudes above 30,000 feet, in temperatures approaching minus 60 degrees Fahrenheit, where the thin air makes every maneuver require conscious effort, and where hypoxia and cold threaten to incapacitate pilots. The results of the March 6 Berlin raid transformed the air war fundamentally. American bombers successfully reach Berlin, drop their ordnance on target, and return to England. The losses are not insignificant. Over 60 American bombers are destroyed, but the losses are sustainable. More importantly, German fighters have suffered significant casualties. Over 70 German fighters are destroyed or damaged irreparably. German pilots report encounters with American fighters that are superior in speed, range, and handling characteristics at altitude. German aces, men with hundreds of victories, encounter the Mustang and discover that their previous experiences with American fighters do not apply. German fighter doctrine assumes that German pilots, trained in rigorous pre-war academies and refined through 4 years of continuous combat, possess inherent superiority over American pilots flying contemporary equipment. Yet the P-51B seems to violate this assumption. American pilots, many of them younger and less experienced than German pilots, are able to compete effectively in aerial combat and often emerge victorious. German ace Walter Wolfram, with 137 confirmed victories, is reported to have said of the Mustang, "When I saw American fighters over Berlin, I knew the war was lost." The comment captures the psychological impact of the P-51B's arrival on German fighter pilots. These men have been told repeatedly that German engineering and German training are superior to anything America can produce. They have witnessed the proof of this superiority through years of combat against inferior American fighters. Yet suddenly, American fighters possess performance characteristics that make German fighters look slow and obsolete. The implications are devastating psychologically, if not immediately tactically. The P-51B's range advantage proves as significant as its performance advantage. The aircraft can fly on internal fuel for distances approaching 2,000 miles with external drop tanks. This range allows American fighters to penetrate to German industrial heartland, engage German fighters in prolonged aerial combat, and still retain sufficient fuel to return to England. German fighters without equivalent range cannot match this operational capability. German pilots are forced to attempt interceptions, knowing they will have limited fuel for combat engagements. They cannot afford to pursue damaged American fighters across long distances, because reaching the limit of fuel reserves over hostile territory means capture or death. American pilots, conversely, know that if they become separated from their unit or if their aircraft is damaged, they might still reach England or friendly territory, even if they must bail out. The psychological advantage of this asymmetry cannot be overstated. German pilots become increasingly reluctant to engage American fighters in prolonged combat, knowing that they are operating on borrowed time and fuel reserves. American pilots become correspondingly more aggressive, knowing they can fight at length and still escape. The emergence of the P-51D variant in late 1943 and early 1944 amplifies the Mustang's advantages further. The P-51D features a bubble canopy that replaces the previous design, providing exceptional visibility for pilots scanning the sky for enemy aircraft. The aircraft mounts 650 caliber machine guns in the wings, providing devastating firepower compared to the 4 guns of the P-51B. The engine is upgraded to the Packard VD1657, a license-built version of the Rolls-Royce Merlin 66 with enhanced performance characteristics. Top speed increases to 437 miles per hour. The rate of climb continues to improve. By early 1944, the P-51D is in production and reaching fighter units in Europe. German pilots encountering the D variant discovered that American fighter performance has increased again. The visibility advantages provided by the bubble canopy translate into tactical advantages. American pilots can see German fighters earlier and can track them more effectively in three-dimensional combat space. German pilots report feeling increasingly hunted rather than hunting. The Luftwaffe High Command begins to understand that long-range American fighters pose an existential threat to German air defense. If American fighters can penetrate to Germany, engage German fighters on favorable terms and still return home, then the Luftwaffe cannot defend German airspace effectively. If the Luftwaffe cannot defend German airspace, then American bombers can reach any target and return, and German war industries become vulnerable to complete destruction. The strategic impact of the P-51B and P-51D becomes apparent through 1944. American bombers strike German synthetic oil refineries, knowing that fighter cover will protect them from the worst of Luftwaffe opposition. German fighter fuel production is destroyed by bombing, which means German fighters cannot fly in the numbers necessary to defend German airspace. American fighters, with their exceptional range, can destroy German fighters on the ground at airfields. The cycle accelerates. As German fuel production declines, fewer German fighters can operate, and fewer German pilots can be trained to replace losses. By mid-1944, German fighter losses exceed German fighter production. The Luftwaffe faces a strategic situation with no solution. German fighters cannot defeat American fighters in aerial combat. German air defenses cannot prevent American bombing. German industries cannot produce fighters and fuel faster than American air forces are destroying them. The P-51B and P-51D have become instruments of a strategic collapse that German military leadership cannot reverse or escape. The famous American pilots of the era, Chuck Yeager, Don Gentile, and others, achieve their highest victory totals flying the P-51D. Yeager achieves 12.5 confirmed victories, with 5 Me-109s downed on a single October day. Don Gentile achieves 19.5 confirmed victories in just 3 months of combat. Other pilots achieve even higher totals. The P-51 becomes the platform for American air superiority in the European theater. German pilots, by contrast, find that even experienced aces with hundreds of previous victories cannot reliably defeat American fighters flying P-51s. The reversal is so complete and so dramatic that German pilots speak of it in their post-war testimonies with a sense of betrayal by German military leadership for allowing American air forces to gain technological superiority, betrayal by their own aircraft's limitations, betrayal by the political and strategic situation that forced them to defend German airspace without possibility of victory. They might transition from early Allison-powered Mustangs dismissed as inadequate to P-51B and D variants that achieve air superiority over Germany represents one of the most dramatic transformations of any military aircraft during World War II. The difference was not in the airframe design, which remained fundamentally unchanged. The difference was in the engine, specifically the Rolls-Royce Merlin two-stage supercharged engine that transformed a mediocre fighter into the greatest long-range fighter of the war. Yet even this transformation would not have mattered had the USAF not recognized the aircraft's potential and accelerated production. 8,000 P-51s are produced during the war, a volume of production that ensures sufficient aircraft are available to equip multiple fighter groups and sustain operations through 1944 and 1945. The combination of superior performance, exceptional range, and overwhelming numbers creates a situation in which German air defense becomes impossible. The few remaining German aircraft and pilots cannot hope to compete. By war's end, the Luftwaffe has been reduced to a fraction of its former size. German fighters are unable to defend German airspace. American bombers roam freely over Germany, striking targets without fear of fighter opposition. The victory is not won by Mustangs alone. Many other factors contribute to the defeat of the Luftwaffe. But the P-51, arriving at the crucial moment and possessing precisely the characteristics needed to solve the problems facing American strategic bombing, becomes the weapon that makes total American victory possible. The post-war analysis of Luftwaffe pilots and German military leadership emphasizes repeatedly the strategic impact of the P-51B and P-51D. German documents capture after the war indicate that military leadership recognized the moment when American air superiority became unchallengeable. Multiple sources cite the arrival of American long-range fighters as the decisive factor. German pilots, in post-war interviews and memoirs, consistently identify the P-51D as the single most dangerous American fighter they encountered. The aircraft's combination of speed, maneuverability, range, firepower, and the exceptional tactical skill of American pilots flying it created a situation in which victory for German fighters became impossible. One German pilot's post-war account captures the fundamental shift. Before the Mustang, we fought American fighters and usually won. After the Mustang, we fought American fighters and usually lost. The difference was not courage or training. It was that American fighters were simply better, and they had fuel reserves we could not match. We were no longer fighting for victory. We were fighting to die over our own country, unable to run home with fuel reserves intact, unable to fight them on favorable terms. It was hopeless, and we knew it. The dismissal of the P-51 as a toy plane by German officers in the early stages of its operational history represents a fundamental underestimation of American aviation capability. German military theorists, trained to believe in German technical and tactical superiority, could not conceptualize that American industry might produce an aircraft superior to German fighters. The shock of discovering that American designers, with fewer resources and less pre-war development time, had created a fighter aircraft genuinely superior to the Bf-109 and FW-190 was psychological as much as tactical. It shattered assumptions that had sustained German military morale throughout the war. If American industry could produce the P-51, what other innovations might American engineers achieve? If American fighters were superior, what hope remained for German air defense? The questions cascaded through German military leadership without answerable responses. The practical answer was none. German air defense had become impossible, and the arrival of the P-51B made that impossibility complete and undeniable. The scale of American production of the P-51 demonstrates the industrial capacity that ultimately defeated Germany. 8,000 Mustangs were produced. That volume of production means that squadrons of fighters could be equipped. Squadrons lost to combat could be replaced. Squadrons needed for new operations could be formed, all while maintaining sufficient aircraft at bases in England and later on the continent to prosecute the air war against Germany. German fighter production, by contrast, totaled approximately 13,000 aircraft of all types during the entire war. Yet Germany was expected to defend airspace across all of occupied Europe and the German homeland against this and other American fighters. The arithmetic was hopeless. Germany could not possibly produce sufficient fighters to maintain air defense across such vast distances against an enemy with superior aircraft and overwhelming numerical superiority. By 1944, when the P-51B and D arrive in large numbers, German air defense has already become impossible. The P-51 merely eliminates any residual doubt about the outcome. German fighters cannot defend German airspace against P-51 escorted bombers. American bombers will reach any target. German war industries will be destroyed. American victory in the air war is now assured with mathematical certainty. The P-51, Mustang's journey from mediocre fighter dismissed by German observers to the greatest long-range fighter of World War II, represents a vindication of pragmatic design philosophy. The original airframe design, with its laminar flow wing and efficient cooling system, proved so fundamentally sound that when paired with a superior engine, it achieved greatness. The aircraft's design emphasized efficiency and range over firepower or armor. Pilots flying P-51s do not benefit from heavy armor protection. 650 caliber machine guns provide formidable firepower, but not the concentrated destructive power of German cannons. What the P-51 offers instead is the ability to reach deep into German airspace, to engage German fighters on superior terms in speed and climb performance, and to fight prolonged engagements without running out of fuel. These characteristics prove more important than armor or cannon firepower in determining victory. German fighters, heavier and more heavily armed, cannot achieve the performance necessary to defeat the P-51 on favorable terms. The battle is decided by superior aircraft characteristics rather than individual pilot skill, though American pilots' increasing experience and numbers contribute substantially to American victory. Epilogue. The rejected aircraft, dismissed as a mediocre fighter in its early form, became the most feared fighter in the European theater by 1944. The toy plane that German officers mocked became the weapon that made German air defense impossible. 8,000 Mustangs were produced, equipping multiple fighter groups and enabling American strategic bombing to proceed without fear of fighter opposition. The P-51B's introduction to combat coincided with the critical transition from German air superiority to American air supremacy. The P-51D, arriving in late 1943 and early 1944, accelerated the transition to complete American dominance. By the war's end, Luftwaffe pilots flying in the skies over Germany were flying either obsolescent aircraft or were confined to the ground waiting for fuel that never arrived or for spare parts that could not be manufactured. The P-51 Mustang had achieved what seemed impossible in 1942, a long-range fighter capable of competing with and defeating German fighters at all altitudes while carrying sufficient fuel to penetrate to German industrial heartland and return home. The aircraft that had been rejected early in its development as insufficiently advanced became the platform for American victory in the air. The transformation from Allison-powered mediocrity to Merlin-powered excellence illustrates a fundamental principle of warfare. The right aircraft paired with the right engine at the right moment in history can change everything. The P-51B and P-51D did exactly that. They changed the air war, they changed the strategic balance, they changed the outcome of the war. German officers who had dismissed the P-51 as a toy lived to witness how that toy transformed their world into rubble. The long-range P-51 made Berlin reachable. It made victory for Germany impossible. It made defeat inevitable. For the Luftwaffe, the arrival of the P-51 Mustang marked the moment when they transformed from hunters to hunted, from the force imposing conditions to the force defending against impossible odds. The greatest long-range fighter of World War II had arrived, and nothing would ever be the same.